Hey, today we're going to look at integrating powers of sine and cosine. And let's jump right into an example. Suppose we look at the integral of the sine cubed of x times the cosine squared of x with respect to x. You could try to do some sort of substitution. It won't get you very far. You could try integration by parts. That will be a nightmare. And so we need some other kind of trick. And the trick is to use a trigonometric identity. And the identity I want to use is the most famous of the trig identities, that sine squared x plus cosine squared x is equal to 1. And if we use that to replace the cosine squared x in this integral in terms of some expression 1 minus the sine squared x, then we'd have an integral entirely in terms of the sine, and it would still be no help. If, on the other hand, we recognize that sine cubed x is the sine of x times the sine squared x, then we can rewrite this integral replacing the sine squared x part with 1 minus cosine squared x, since those two things are equal. And now we have an integral that is ripe for substitution. In particular, if we let r equal the cosine of x, then dr is the negative sine of x dx. We don't quite have that, but we do have the sine of x dx. Multiply both sides by negative 1 to get that negative dr is the sine of x dx. Here's our sine of x dx, which is a negative dr. Everything else is in terms of the new variable r, which is the cosine of x, and that lets us rewrite the integral. We have that the 1 minus cosine squared x is 1 minus r squared. The cosine squared x is r squared, and then the remaining sine of x dx is negative dr. And you can see that I brought the negative sign out in front of the integral. And now I have a new integral entirely in terms of the variable r, and it's not a hard integral. It requires a little bit of algebra first, and you distribute, and then you integrate. Be a little careful. The negative sign is multiplied by the entire answer, and so after you distribute that negative sign at the end, you get your negative 1/3 r cubed plus 1/5 r to the 5th plus a constant, and r is the cosine, and that's what gives us the answer that we have here. And the key aspect of this integral that allowed us to make some progress was that we had an odd power of the sine, so that we could leave a single power of the sine behind and turn all the rest of it into cosines, and then use substitution. Anytime you have an odd power of the sine or the cosine, you can do this same trick using this identity, sine squared x plus cosine squared x equals 1, and then just turn it into a substitution problem. All right, you try this one. Try to leave a single power of the cosine behind and turn everything else into powers of the sine, and then let r equal the sine of x and do your substitution from there. Give it a moment, a minute, 2 minutes, however long it takes. Pause the video. When you're ready, start it back up again, and we'll do it together. Okay, lots to see here, but the basic idea is that cosine to the 5th of x is the cosine of x times the cosine to the 4th of x. And you can write the cosine to the 4th of x as cosine squared x all squared, or if you prefer, cosine squared x times cosine squared x. That's what I've got in light blue there. That gets a little bit more awkward if it's higher powers, but will work for this one right here. And then you can replace cosine squared x with 1 minus sine squared x from the trig identity that we have. That lets us, now we have the integral entirely in terms of the sine, except for a single value of the cosine times the dx. So we can let r be the sine of x, dr is the cosine of x dx, and that lets us rewrite the entire integral in terms of r. We get the integral of r to the 4th, that's the sine to the 4th of x, times 1 minus r squared all squared, that's the 1 minus sine squared x all squared, and then cosine of x dx is just dr. And so now we have a new integral all in terms of r. It's a simple integral. There's a bunch of algebra to do, so you follow along the algebra there. I've done it out carefully. You have to be careful with your powers of exponents or your properties of exponents. And then you get some, the integral is not hard to do. It's just a polynomial, so you get some nice answer there that you have to turn back in terms of the sine in order to complete the problem. So take a careful look at that, make sure you understand, and then we'll move on. Okay, that's essentially what you do anytime you have an odd power of the sine or the cosine that you're working with in an integral. But you are undoubtedly asking yourselves right now, what if I only have even powers of the sine and the cosine, in which case that trick won't work. If you only have an even power or even powers of the sine and cosine, then you need a different trig identity. Well, there are a whole lot of trig identities, and there are too many to memorize. Personally, I like to memorize precisely 3 of them, and then use those to figure out the ones that I need. So I'm going to show you how to do that in a second. And then if you decide that you want to memorize the ones that are actually more pertinent to these problems, great, go ahead and memorize them, but make sure you memorize them right. I see a lot of people who memorize them wrong and then just get the problems completely wrong, and they're not hard to figure out. So let's take a look at a few trig identities and then do some integrals that only have even powers of sine and cosine. We'll start with the one we've already seen, possibly the most famous and most important of the trig identities, sine squared x plus cosine squared x equals 1. You certainly need to know that. You also need this trig identity that the cosine of 2x is the cosine squared x minus the sine squared x. And although we won't need it today, you will also need to know that the sine of 2x is twice the sine of x times the cosine of x. That will become important very soon. Okay, start with the second of these identities, that the cosine of 2x is cosine squared x minus the sine squared x, and then use the first identity, sine squared x plus cosine squared x equals 1, to rewrite cosine squared x, so that cosine of 2x is 1 minus sine squared x minus sine squared x. Now do a little algebra and solve this equation for sine squared x, and you get the first of the important trig identities that we'll need in order to compute integrals of even powers of sine and cosine. It's that the sine squared x is equal to 1/2 times 1 minus the cosine of 2x. Okay, 1 down, 1 to go. Start again with that second trig identity that the cosine of 2x is cosine squared x minus sine squared x. But this time, instead of replacing cosine squared x using the first identity, let's replace sine squared x, so that the cosine of 2x is the cosine squared x minus the quantity 1 minus the cosine squared x. Again, we do a little bit of algebra and solve for the cosine squared x, and we get the cosine squared x is equal to 1/2 times 1 plus the cosine of 2x. That's the other important trig identity related to integrating even powers of sine and cosine. And as I said before, you're welcome to just memorize them, but make sure you memorize them correctly if you're going to memorize them. Otherwise, personally, I would suggest take the 47 seconds that it will require on a quiz or an exam, use these trig identities that are easy to memorize, and a little bit of algebra, and work these out so that you're sure that you get them right. Let's do a quick example, and then I will set you loose on your homework. Let's take a look at the integral of the cosine squared of 5x dx. In case the x's are confusing you, or the x versus the 5x is confusing you, it might help to rewrite the trig identity in terms of a new variable. Theta is very common. For example, cosine squared theta is 1/2 times 1 plus the cosine of 2 theta. Or to put it another way, cosine squared of anything is 1/2 times 1 plus the cosine of twice that anything. And in particular, the cosine squared of 5x is 1/2 times 1 plus the cosine of twice 5x, which is 10x. This is not a hard integral. We can do it by substitution. We pull the 1/2 outside of the integral, and we let our r equal 10x. Since r is 10x, dr is 10 dx. We don't have a 10 dx, but we do have a dx. So we can divide both sides by 10 and get that 1/10 dr is equal to dx. This lets us rewrite the original integral in terms of the new variable r. The cosine 10x becomes a cosine of r, the 1 stays a 1, and the dx becomes a 1/10 dr, and we can pull the 1/10 outside of the integral because it's a constant. Combining the 1/10 and the 1/2, we have 1/20 the integral of 1 plus the cosine of r dr. This is a very easy integral. You have to be a little bit careful. The integral is with respect to r, so the integral of 1 is r, and you get 1/20th times the quantity r plus the sine of r, all plus a constant. Turning this back in terms of x, r is equal to 10x, and then all that's left is to simplify. And distributing the 1/20th, 10 over 20 is a half, so you get 1/2 x plus 1/20th the sine of 10x plus a constant. Okay, that's what you need to know about integrating powers of sine and cosine. Give the homework a try. See you soon.